Alright, on this video we're going to go through examples 6 and 7, so that'll be the last two questions for your quiz review. 6 and 7 are both have to do with the shell method. So, find the volume of the solid obtained by rotating about the y-axis the region bounded by y equals 3x squared minus x cubed and y equals 0. So we're going to take this equation, y equals 3x squared minus x cubed, and I'm going to factor that out so I can get a better idea of what that picture is going to look like. So factor out an x squared, and then we have 3 minus x left over, and then let's sketch out a picture over here. So I know that zeros, this is a cubic function. I also know that it's a negative cubic function. So its end behavior is going to start up here and end going down in quadrant 4. And I know that it has zeros at 0. That is also a double root. And then it also is going to have a 0 at 3. Alright, so it's going to be coming down from here. I'm not going to graph that in because we're starting at y equals 0. And then it is going to bounce off of that 0, come up, and then go back down. Now, I actually don't even have to find the height of this function, which makes it really nice. I am going to kind of try to draw the region that we're looking at. So, it would reflect that about the y-axis. It comes about here. Good. Alright, and then we are rotating that around the y-axis. And then all of this region is going to be colored in. So with this method, with the shell method, we are going to take one slice, and this is going to be a dx. So this is what's a little bit different about this method, is we are revolving around the y-axis, but it actually ends up being an equation that we integrate in terms of x, which is really nice. We don't have to change that equation over. So when we take this one section, a shell is a section that goes all the way around that, our shape. So we're going to take that shell and we're going to take it out and cut one little piece of it and roll it out into a rectangle. So when we roll that out, we end up with the length being the circumference of the circle. So the circumference of the circle, I want to do it in terms of radius so that I can integrate. My limits of integration will be in terms of radius. So 2 pi r, and the height of this is equal to our equation. So the height of each one of our rectangles is going to be the equation f of x. And that's the first question that it asks us. So let's go ahead and fill that in. It says a typical shell has radius x, circumference 2 pi x. Now, why are they saying x? I haven't gotten that far yet. I just said radius, but notice that wherever our shell is, the radius is going to be the same as whichever x value we're taking it as. So our circumference becomes 2 pi x, and our f of x that we're using for the height is 3x squared minus x cubed. So then, by the shell method, the volume is equal from 0 to the integral, and then we have to fill in here, the integral from 0 to a of 2 pi x times 3x squared minus x cubed times dx. And the reason that that is because 2 pi x is the length of my rectangle. This is the height. So my area of one section is equal to 2 pi x times h, which is an equation in terms of x. So we could say h of x. That's what I've put in here. And a, what does a equal? If we look back at our picture, how far did we go? From here, 0 to, remember what this amount was right here? That was 3, where x equals 3. We got that from our zeros when we graphed our pictures. So a is equal to 3. So what we're actually going to evaluate to find our volume is the equation. I'm going to pull out 2 pi from 0 to 3 of x times 3x squared minus x cubed dx. Let's multiply that x through, and we get 2 pi integral from 0 to 3 of 3x cubed minus x to the 4th dx. And we're ready to integrate. So we have 2 pi times 3 over 4 x to the 4th minus 1/5 x to the 5th. Now, they want an exact answer on this one. So, as I'm going through and evaluating, I'm going to evaluate a little differently. Just try to pull out as much as I can from these fractions so that I can simplify it and get an exact answer. So plug in 3. The 0 is going to just be 0, so I don't have to worry about the second half of that evaluation. So 2 pi, and then I have 3/4 times 3 to the 4th minus 1/5 times 3 to the 5th. Now I'm going to factor out everything that I can. So I've got a 3 to the 5th here, I've got a 3 to the 4th here, but I also have another 3. So if I multiply that 3 in, I'd have another 3 to the 5th. So let's go ahead and factor out a whole 3 to the 5th. Then what's left inside our parentheses? Then we're going to have 1/4 minus 1/5, which could be rewritten in terms of 20. So let's do a different color. So if I wanted to write 1/4 in terms of 20ths, then I'd have to multiply both top and bottom by a 5. So I'd have 5 over 20. And then here I'd have to multiply both top and bottom by a 4. So I'd have 4 over 20. 5 minus 4 would be 1. And it's still over 20. So 2 pi times 3 to the 5th times 1/20. Then our 20 and our 2 will reduce. We'll have 10 left here. 3 to the 5th, make sure I'm looking at my right one, is 243. So I have 243 pi over 10. And that is your final exact answer for number 6. And on to example number 7. So example number 7 has a nice picture already for us, but we don't have all of the information that we usually glean from a picture when we graph it. So let's go ahead and still look at our equations. We have the region bounded by f of x equals negative 4x squared plus 16x plus 48, x equals 0 and y equals 0 is rotated about the x-axis. Find the volume of the solid of revolution. Well, I do not know what to set my limits of integration to. Now I know my equation. My equation to find using the shell method is 2 pi x times f of x dx. All right, I'm good there, but I need to figure out what my a value would be. So to do that, you can kind of see inside of this picture, it's see-through, you can see our original equation. So this is going to be 0 in here, and then this is some value out here. This is the value that I need to know, because that is going to be our limits of integration. So to figure that out, let's take our equation. Y equals negative 4 x squared plus 16x plus 48. Let's simplify it as much as we can. I'm going to set this equal to 0 because I want to know where it crosses the x-axis or what the zeros are. So first thing I'm going to do is factor out a negative 4. And what's left is negative x squared. Whoops. Negative x squared minus 4x minus 12 equals 0. Then I can divide both sides by that negative 4, and then that factors nicely to x minus 6, x plus 2. So that gives me zeros of x equals negative 2 and x equals 6. This negative 2 here, this is not going to help me any because it is past that's where it would come down over here. And we are only looking from 0 because it states up here we have x equals 0. So that x equals 0 line also needs to be adhered to. All right, so that's why we know we can start at 0 at the bottom. Then a, we also have x equals 6. So that must be 6. And so that is where our limits of integration are going to be to. So we'll have the integral from 0 to 6 of 2 pi x times negative 4x squared plus 16x plus 48 dx. Okay, and multiplying that x through and pulling out the 2 pi, we have 2 pi from 0 to 6 of negative 4x cubed plus 16x squared plus 48x dx. Now let's go ahead and integrate. So the integral of that, we're going to have 2 pi times negative 4 over 4 x to the 4th, parenthesis here, plus 16 over 3 times x cubed. And we want an exact answer on this one too. I'm probably going to have to give myself some more room here in a minute. 16 over 3 x cubed plus 48 over 2 x squared. And then we are evaluating this between 0 and 6. So let's simplify that equation. We have 2 pi negative x to the 4th plus 16 over 3 x cubed plus 24 x squared. All right, I'm going to do one more thing. I'm going to go ahead and pull out an x squared. So that'll give me 2 pi, 2 pi x squared times negative x squared plus 16 over 3 x plus 24. And we're evaluating that from 0 to 6. All right, and now I'm going to pause for a second and erase my top. Okay, because I only have a minute and a half left, I went ahead and wrote all of this out. So you can go ahead and pause if you need to catch up. All I did is rewrite what I had at the bottom of the page here, and then I plugged in the 6. So from there, let's look and see what happens inside our parentheses. We have at negative 36 plus, then I'm going to reduce this. 6 and 3 are going to cancel to 2. So negative 36 plus 32 plus 24. And then I have 6 squared out in front and a times 2. So that's going to give me a 72 pi out in front. And then I'll have 20. All of this will reduce to 20. And I will have 1440. Yep, 1440 pi. Because they do want an exact answer, I believe, on this one. So 1440 pi is our final answer. All right, so I really like the shell method. I hope that you guys too, and that makes sense to you. And hopefully we'll get a time to talk together before you guys take your quiz. And let me know if you have any other questions.